The biological preservation of skeletal muscle mass in the later decades of human life is not a matter of aesthetics, nor is it a pursuit of athletic vanity. It is a critical, high-stakes medical mandate that dictates the ultimate trajectory of your functional longevity and metabolic survival. As the human body crosses the threshold of 60 years, it enters a state of progressive, silent, and aggressive physiological vulnerability known clinically as sarcopenia. For decades, the medical community and the public were pacified with the narrative that this wasting away was simply an unavoidable consequence of chronological time. The shrinking of the arms, the flattening of the quadriceps, and the overarching sensation of physical frailty were seen as normal aging. However, modern molecular biology and cellular gerontology have completely dismantled this defeatist paradigm, identifying the true culprit of age-related muscle loss, a devastating metabolic condition known as anabolic resistance. In a 60-year-old body, the muscle cells do not simply shrink because they are old. They shrink because they essentially become deaf to signals of growth. You can consume adequate daily calories, and you can engage in light physical movement, but your body may still refuse to assemble new myofibrillar tissue. If you do not cross a very specific, highly elevated biochemical threshold, your body will initiate a process of catabolism. It begins cannibalizing its own skeletal muscle to harvest amino acids for the maintenance of vital organs, leaving you in a state of permanent metabolic bankruptcy, threatening your very survival. To fully grasp the magnitude of why your muscles are shrinking and exactly how to hijack the system to stop it, we must first look deep into the intracellular signaling pathways, specifically focusing on a microscopic enzyme complex known as the mammalian target of rapamycin, or mTORC1. In human physiology, the mTORC1 complex acts as the absolute master regulatory switch for muscle protein synthesis. It is the molecular general that sits inside the muscle cell, sensing the nutritional and energetic environment, and ultimately commanding the ribosomes to start reading mRNA and assembling new muscle proteins. In youth, the mTOR pathway is highly sensitive and easily triggered. A minor influx of protein is enough to flip the switch on. But as we age, systemic low-grade inflammation, oxidative stress, and the rigidification of cellular membranes cause this switch to become blunt and highly resistant to activation. To break this resistance, the body requires two simultaneous signals: a massive surge of the amino acid leucine and a fundamental restoration of the cell membrane's fluid dynamics. This is where most seniors fail, as they consume small, frequent amounts of protein that never reach the anabolic threshold, leaving their muscles in a state of permanent dormancy, while the body continues to degrade its own structural foundation. The first essential component of this muscle switch protocol is the achievement of the leucine threshold through a massive, concentrated protein bolus. Leucine is a branched-chain amino acid that serves as the absolute biological key to the mTOR pathway. It is not just a building block, but a signaling molecule that physically binds to sensors inside the cell to authorize growth. For an individual over 60, the medical reality is that you require a minimum of 3.5 to 4 grams of pure leucine to trigger this response. The most efficient way to achieve this is through 35 to 40 grams of high-quality protein, specifically whey protein isolate, or 5 whole eggs. When this bolus hits the systemic circulation, it creates a high-velocity spike in amino acids that overcomes the blunted sensitivity of the aging mTOR switch. By providing this massive signal during your first meal of the day, you effectively pull your body out of the overnight catabolic state. You forcefully initiate the assembly of new muscle fibers, a process that would otherwise remain dormant under a standard low-protein breakfast of toast or cereal. However, a leucine spike alone is often insufficient if the muscle cell membranes are rigid and inflamed, a common hallmark of aging. This brings us to the second, and perhaps most critical, biological agent in the protocol: high-dose omega-3 fatty acids, specifically eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, from wild-caught sardines or mackerel. After age 60, The phospholipid bilayer that forms the skin of your muscle cells becomes progressively stiffer due to years of oxidative stress and a diet high in pro-inflammatory seed oils. When the cell membrane is rigid, the insulin and amino acid receptors cannot move or function correctly. They become stuck, preventing the anabolic signals from reaching the mTOR complex. By flooding your system with high-dose omega-3s, you are initiating a process of membrane remodeling. These long-chain fatty acids are physically incorporated into the muscle cell membranes, restoring their youthful fluidity and elasticity. Clinical trials have demonstrated that when seniors combine high protein intake with high omega-3 levels, the rate of muscle protein synthesis increases by up to 50% more than with protein alone. You are essentially greasing the cellular machinery, allowing the anabolic switch to be flipped with far less resistance. The third pillar of this strength restoration protocol addresses the bioenergetic and hormonal requirements of the muscle cell through the strategic intake of magnesium and zinc, ideally sourced from pumpkin seeds or high-quality supplements. Building muscle is an extremely energy-intensive process that requires vast amounts of adenosine triphosphate, ATP. Magnesium is the required cofactor for every single reaction involving ATP. Without it, the cellular construction crew has no fuel to build new protein chains. Furthermore, magnesium acts as a natural calcium antagonist, allowing the muscle fibers to fully relax after a contraction, which is essential for preventing the chronic muscle tightness and cramping that limits mobility in older adults. Simultaneously, zinc serves as a foundational element for the production of endogenous anabolic hormones and the regulation of DNA polymerase, the enzyme responsible for duplicating genetic material during tissue repair. In the aging demographic, where mineral absorption is often compromised, providing a concentrated daily dose of these elements ensures that the hormonal environment is optimized to support the growth signal initiated by the leucine and omega-3s. Even with the perfect orchestration of amino acids, fatty acids, and minerals, the protocol will fail if the nutrients never leave the gastrointestinal tract, leading us to the silent epidemic of hypochlorhydria. As humans age, the parietal cells in the stomach atrophy, producing significantly less hydrochloric acid. This is catastrophic for muscle building, as dietary protein must be physically denatured and unfolded by stomach acid before the enzyme pepsin can cleave it into absorbable peptides. Without adequate acid, that 40-gram protein bolus will simply sit in the gut, causing putrefaction, gas, and systemic inflammation, while your muscles remain starved of amino acids. To ensure the muscle switch is successfully powered, you must chemically support the digestive environment by consuming 1 to 2 tablespoons of raw apple cider vinegar diluted in water 10 minutes before your anabolic meal. This exogenous acidic catalyst drops the gastric pH, activating the proteolytic enzymes and ensuring that the heavy payload of protein is successfully dismantled and absorbed into the portal vein for immediate utilization by your skeletal muscles. Beyond the chemical inputs, the final command for muscle accretion is mechanical. The mTOR pathway is exquisitely sensitive to mechanotransduction, the process where the muscle cell detects physical tension and converts it into a chemical growth signal. For an individual over 60, this does not require heavy powerlifting, which may be hazardous to aging joints. Instead, it requires providing a load signal immediately before the anabolic meal. Engaging in just 15 minutes of resistance training, utilizing bands, light weights, or slow, controlled bodyweight movements like chair squats, creates a localized metabolic sink. The mechanical stress causes a temporary increase in the density of amino acid transporters on the surface of the worked muscles. When the leucine spike from your breakfast hits the bloodstream an hour later, the exercised muscles aggressively vacuum the nutrients out of circulation to repair the microscopic mechanical damage. Without this movement signal, the body has no reason to invest its precious energy into building expensive muscle tissue, and the protein you eat may be diverted to less desirable pathways. When this multifaceted intervention, the 40-gram leucine-dense bolus, the membrane-sensitizing omega-3s, the energetic mineral support, and the acidic digestive catalyst, is maintained with uncompromising consistency over a 30-day cycle. The internal physiological shift is nothing short of a systemic metamorphosis. The initial changes manifest in the realm of neuromuscular efficiency. The pervasive sensation of frailty and the heaviness in the limbs begin to evaporate as the mitochondria within the muscle fibers become denser and more efficient at producing energy. By the end of the month, the macroscopic results become clinically evident in the form of increased grip strength, improved balance, and the restoration of a stable, confident gait. Furthermore, this newly built muscle acts as your primary metabolic insurance policy, pulling excess glucose out of the blood and lowering the systemic inflammation that drives chronic disease. By providing your cells with this precise chemical and mechanical information, you are reclaiming your biological authority, ensuring that your later decades are defined not by the limitations of decay, but by the resilience of a body that remains powerful, independent, and architecturally sound.